what we shall expect. Right. Paper 2 is made of measurements. Then it's made of maps and plans, and a little bit of probability. Measurements will contribute 55% of the question paper, which is approximately 83 plus 83% of the paper. Sorry, 83 marks out, because this paper is out of the paper is out of 150. So 55% of 150 is 80. It's 82.5, which is 83. You see that? Then 40% of the paper becomes 60, and 5% of probability, which is 7%. So these are the topics that we expect in paper 2, and this probability crosses through paper 1 and paper 2. But how much does measurement contribute? It contributes 5%, which is 83 marks out of 150. Whereas maps and plans, it's 40%, which contributes 60% of 150, remaining with 7%. So remaining with 5% of the paper, which contributes 7 marks, is probability. All right, let's look at the splitted measurements now. We look at that. Now, this is how a question would be. Question 1, we expect it to be a little bit integrated. All right, these are short, simple questions. We call them level 1 questions, straightforward questions. All right, so we are saying mixed questions, and we expect to be asked about maps, the plans, and measurements. We shall see this in details. Then question number 2, strictly to be on maps and plans. Definitely expect, when you look at maps and plans, you expect to hear the word scales, which will probably, we shall use them to determine the either actual distance or distance of the map. All right, measurements. When you look at measurements, we shall be looking at things like area, perimeter. Then we look at volume and surface area. Surface area. Please, when it comes to paper 2, units are so important. When it comes to question number 4, we expect it to be a mixture of maps and plans, a little bit of measurements, and 5, little bit. This we call them integrated if it goes to 5. Then we shall expect a little bit of finance, but in a sense of you looking for the cost. For example, if someone had to travel from a certain place, from one place to another, how much will they pay for the petrol? If someone is to cover a certain area with the tiles, how much are they going to pay? That small bit of finance, which to only be looking at cost. And don't forget, it could be also looking at a little bit of profit. How much does he make, or how much does he lose? You know, we shall ask you to verify the so and so claims to have spent this much on labor, buying material. Is it true? All right, this is what we are looking at, but it won't be that deep finance of you looking at statements and the interest. All right, let's go in depth and we see measurements. When you look at measurements, which contributes 55% of the question, it has to be made. Yes, when you look at conversions, I want you to remember that there are 2 systems that we use under conversions. One being metric, which is used in most of the African countries, and the 2 being imperial. All right, I will just give units, then you understand. Metrics uses, if it was distance, it would be kilometer, meter. We look at centimeter and millimeter. This is metric. If it was mass, it would be kilogram. We have grams, then we have milligrams. If it was water, I'm talking of volume. We should have kiloliters, liters, and milliliters. This is what we call, this is all about metric. Then when you look at imperial, we look at miles if it's distance, yards if it's length, Then we look at feet. Eventually, we look at what? Inches. You understand? We look at gallons if it's volume, gallons. We look at gallons. We look at ounce. All right. Then we look at fluid ounce. We look at pints. We look at quarts. You understand? If it's mass, we look at pounds. Ounce. We have what we call ounce still. Then we look at so-called stone when it comes to mass. All right, these are imperial. So in these questions, paper 2, we shall expect you to memorize this. This has to be in your memory. You have to remember them off heart. These will always be provided by the examiner. All right, conversion. We asked, this is conversion whereby we shall be changing. We convert from one unit to another unit. So one unit to another unit. This is what we call conversions. All right. So whereby you also, as you memorize this, you also have to remember that whenever you're changing from small to big, you need to divide. Whereas big to small, you will have to multiply. This should also be hand in hand. When we look at conversions, especially the kilometers, meters, centimeters, and millimeters, these have 3 stages, and each stage has its own value. So from kilometer to meter, we have 1,000. Then meter to centimeters, we reduce 1 0 goes off, we remain with 100. Then centimeter to millimeter, you remain with the 10. These are the values that you always remember. So if you're going, which is from big to small, you always multiply. And when you're from small, you're heading to big, you always need to divide. You need to take note of that. All right. So this was length. Then weight, the same story, which is kg. Then we go to grams, then milligrams. These ones, they don't have any stay here. We only have 1,000 in between. Same will apply to water, which is kiloliter. But still it happens like the same theory happens. Big to small you multiply, and small to big you divide. This happens throughout. But now for mass and water, we have 1,000 only in between. We don't have 1,000, 110. No. Then we go to volume, whereby we also have kiloliters, followed by liters, and lastly milliliters. Also, these have 1,000 in between. These have 1,000 in between. All right, these are measurements. Remember, it contributes to the exam for the final mark 55%. So if you're conversant with this, you can easily get a distinction. All right, let's come to temperature. Temperature also is divided into two, but you always be given a formula. There's a formula. We have the Celsius, degrees Celsius. Then we also have the other one with F, which is Fahrenheit. Fahrenheit degrees. So this is used when you're changing from Fahrenheit to Celsius or centigrade. All right. Then what about if you're moving from Fahrenheit to from Celsius to Fahrenheit? Then it becomes it will become this much. These formulas sometimes they're provided, but they might provide them upside down. But don't worry, learn how to make one the subject. But these are the formulas. If the formula is given, look at it and understand what they want. For example, they might ask you, let's try out this. For example, they might ask you, to provide, for example, convert 54 degrees Celsius to Fahrenheit. You see this? So they have given you 54 degrees Celsius and they want you to become one Fahrenheit. But the formula they have given you is for Celsius. So in your head, you have to sit down and say, man, I have Celsius. So Celsius, the 54 comes here, which equals to the one I'm looking for, into brackets minus 32 divided by 1,8. So for us to remove the 1,8, we need to multiply 1,8 on both sides. What happens on the right happens in the left. So these ones they will go, whereby you remain with Fahrenheit minus 32. So when you multiply this, you end up having 1,8 times 1,8 times 54. You end up having 90,2. So 90,2, what do you do? This is a minus. This has to cross over. So in that it becomes a plus. So our Fahrenheit will become 97,2 plus 32, which becomes 129, comma 2. 97,2 plus 32. Get 100. So the reason why I gave you this example is because sometimes they might give you the formula which is upside down. Take note of that. Then this we from temperature we've seen that Fahrenheit, we shall say Fahrenheit will equal to degrees times 1 comma plus 32. That's what we shall say. All right, then we come to perimeter. Perimeter, what we want you to know, it's the total distance around an enclosed space. Someone might choose to say around a given shape. You understand? So perimeter, it will change according to which shape you're looking at. Then when it comes to area, this is the enclosed what? Enclosed space or surface. The area, the floor on which you stand or the floor which is occupied. It's an area. Volume is the space occupied by a 3D shape. And it becomes an object. All right, we shall look at also time. Let's see the formulas that we need in perimeter, area, and volume. Area, perimeter. All right. We have shapes. Let's say we shall write the shapes. So shapes, we shall look at their formulas and units. So we can start with a circle. Then we have a square, a triangle. Then we have also a rectangle. So if we are to look for its area, what formula are we going to use? If we are to look for the perimeter, what formula are we going to use? That's why I'm doing this. So for a circle, the area will always be pi r squared, where pi is a constant value. All right. Then perimeter of a circle is called the circumference. Circumference will always be pi d, or 2 pi r, where we are saying where r is the radius, as you know it, d is the diameter. When you add it to radii, you get the diameter. If you're looking for the radius, that means it's half of the diameter. Then pi will always be a constant number, which is 3,142. It's a standard number. Some other people want to use 22/7, but we shall use what is given to us. All right, let's look at the square. Square has all sides equal. That means its area will be L times L. Its perimeter will be 4 times L. A triangle has 3 sides equal. Sorry, 3 sides. So its area is a half times base, not breadth. And times what? Height. All right. Whereas its perimeter, since it has 3 sides, with side 1, side 2, plus side 3. A rectangle has 4 sides and two opposite sides equal. So its area will always be length times what? Breadth. The perimeter will be 2 into L plus. Don't forget that. I'm going to write down the units here. The units for area, they will always be squared, whereas the units for perimeter, they remain the way they are. These are the formulas that you might be required to remember a little bit, especially the one for rectangle, perimeter of a rectangle, area of a circle, perimeter of a circle. Those ones you have to remember them a little bit, because they might or they might not provide them to you. All right. All right, we look at the formulas for perimeter and the area. Volume. Volume, this concerns 3D, which are, we are looking at objects. Actually, volume goes hand in hand with surface area. And mainly, we look at 2 objects. One, the rectangular prism, something like this. We can say looks like a box, which is true. Cardboard of something. Yes, a shoe box. Some people might say it looks like a matchbox, rectangular. So when it comes to rectangular, the longer side, we shall always call it length. The shorter side, the breadth, and the one that goes up is called the height. And if you're to find the volume of such, we shall say volume equals to length times breadth times height of a rectangular prism. Then, how shall we get the surface area of a rectangular prism? Surface area of the rectangular prism, allow me use SA. SA standing for surface area. This will mean, since this box, it has actually how many sides? It has 6 sides, but opposite sides are always equal. So this is why we start with a 2, not to avoid repeating. So 2 into L times B, that's one side, plus B times H, that's another side, plus L times h. Complete. So these are three sides, but when you multiply by 2, you get 6. This is how we get the surface area of a rectangular prism. A rectangular prism. A rectangular prism. All right, we look at the other part that I was still looking at. We have what this one here. This is what is usually examined. A cylinder. This is called a cylinder, and its volume will always equal to pi r squared h. This reminds me of the general formula of volume. The general formula. The general formula for volume is you take the base area and you multiply it with the height of that given shape. Base area times the height. Base area times the height. This is the general formula for volume. Because take a look at it. This is a rectangular part. But when you look L times B, this is the formula for area. And they multiplied by the height. Then this is a cylinder. Its base is a circle. Its base is a circle. So if you were to look for the base of the circle, we use pi r what? Squared. Then afterwards multiply by the height. So if you happen to have another one that is so like this, this means if you look for the area of this, it will be the area of this triangle here, which is half. So if you to look for the volume, it will be the area of the triangle, which is half base height, times this other part here, which you would call also the height if you made it go up. You understand? Because here, this one will require this h. So you find the area of the triangle times this is how we shall do it. If you happen to get a shape like this. All right. This is what happens. We've not yet looked at the volume, surface area. Surface area of the cylinder. Surface area of the cylinder will be, because there are two circles. There are two circles. That simply means its surface area. We are adding the area of the two circles, 2 pi r squared. All right, plus 2 pi r h. But I prefer the shortest one. You factorize. What is common here? We see 2 pi r, 2 pi r. So I pull out my 2 pi r into brackets. This was a squared, so it remains plus. Because this one's already out, we don't need to repeat it. What do we remain with? We remain with h. So I usually use this. Why do I use this? To avoid repeating. Here there are too many repeatings, and someone might miss the r. All right, that's how we do it. All right, we look at time, and we look at the sensitive part of time, which is duration. All right, we've just seen volume. So when it comes to time, time also is split into two. There's one that we call the analog. The analog, people call it the 12-hour. The 12-hour system. Whereas we have another one called the digital, which is supposed to be the 24-hour system. And what you have to know, here we allocate time AM or PM, whereas in 24-hour system, we don't include anything. There's nothing like that. So if you're to change, actually, they will be the same from morning until noon. They are always the same. Then past noon, analog returns to 1, whereas digital continues to 13. So simply meaning when you're changing from the analog to digital. In the afternoon, which is PM, you add on 12 hours. Whereas in the morning, AM, everything what? Is the same. Is the same. All right. All right. Let's look at how we do the duration. This is what we call duration. Time taken to accomplish a given activity. Time taken to accomplish a given activity. So duration, we shall always get the end time, the time when the activity stopped, minus the time when it started. Duration to always be end time minus the time when it started. And make sure before you subtract, make sure they are in digital format. Unless when it was morning. But if it's afternoon, make sure they are in digital format. Example, if one starts working at 9:48 a.m. and they finish their work at around let's say 3 3 3:35 p.m. and you asked how long did they do their work. So we change now. This one, this is the start time. This is the end time. This start time, if you change it to 24-hour system, which is the digital format, it won't change that much. It will remain the same way. But this other afternoon one, this one becomes 15:35, no more PM. So easy. Remember, we are saying we are looking for duration, which is the end time, which is 15 minus 0.40. So there's a key on the calculator. It looks like this. All you're going to do, you press 15 and you press that key. You press 35, you press that key. Minus 0.9, you press that key. 48, you press that key. All right, so 15, press the key, 35, you press the key, minus 0.9, you press the key, 48, you press the key, and you press equals. So the person worked for 5 hours, 49, 5 hours, 49 minutes. This is how much the person worked. This is about time. And this will be needed when we shall be looking at maps, because we expect us to do distance and the time. When we look at maps, we shall be looking at that. People call it DSTV. This triangle here. We shall learn how to use it. Yes, we come back and we look at time. Another thing with time, it's supposed to be converting time. Example, they might tell you express 4,800 seconds in hours and minutes. So you ask yourself, how many seconds are in 1 hour? Yeah, 3,600. Definitely, this is more than an hour. So we divide 4,800 4,800 divided by the 3,600. So you get the answer as, you get your answer as 1,333 recurring. So simply meaning, since you're changing the first at what, so the first it's 1 hour. So what is remaining, it's going to be changed into minutes, but they are hours, but not full hours. So 033 recurring. So what we do, hours to minutes, we multiply by 60. 60, and the answer becomes 20. So they are 20 minutes. So your final answer is 1 hour, 20 minutes. Which is okay, because if you were to change back the hour to seconds, you would say 60 minutes times 60 get you 3,600 plus change the 20 minutes to seconds. So here we have 3,600 plus 1,200. Answer comes back to 4,800. These are what? Seconds. I was putting it back. So another thing is to do, you would the moment you divide 3,600, sorry, 4,800 divided by 3,600, you press equals and you press the other key that I showed you, you still get your answer. It will show as 1 like that. So this will be 1 degree represents 1 hour, and the 20 will represent the minutes. Okay. Another way, they might tell you also, express 7.2 hours into minutes. Minutes. So here, so simple, you only do 7.2 times what? 60. You should know how to change that. So it becomes 3 is what? Minutes. Hours to minutes multiply by 60. Minutes to seconds multiply by 60. So it will happen the other way around. You divide if you're turning around. Okay, we look at another concept in paper 2, which is maps and scales. Maps and scales, we shall be looking at layouts. For example, we have sitting plans. Here we will expect for maps and scales. One, for maps is what we call general direction, cardinal direction, or general direction, whereby we look at north, east, south, and west. We shall be, the moment you hear give the general direction of a certain place from another place, we think about this. Having done that, there's also what we call the grid. When we look at maps, this is what we expect. General direction, grid reference. Grid reference, we have another one called the route description. Route reference, referencing a place, a route description. You tell what's going on. You tell what's going on. General direction would be the relative direction. Yes, also it's a relative direction or relative position. Route description, you tell someone, here, don't forget you mention the places you're passing. Pass the shell, turn right, turn left when it comes to route description. Then another thing that we should expect you to know when it comes to maps, how to calculate a distance using the scale. You determine the speed given a time. So that's why you have to know the concept of time. You know how to measure the distance. Now you can look for speed. And we shall always say speed equals to distance over time. Time will equal to distance over speed. And distance will always be speed times time. These are the formulas that you need to remember when it comes to that. Now, the layout buildings, these are spots. Here we expect you to know how to direct someone to move around the given place. The layout of shopping malls. Where do you find a certain shopping shop? Shop number L4, that is why they ask you also, in malls, we have what we call the information desks. Why are they located next to the entrance? Why are they located in the center? You know, that is it. The seating plan, how people are arranged. You've seen people sit in B2, then others are in C4. Why do we have seating plans? So simple to make your work organized and to uh, keep track of the empty seats. Imagine you had a cinema that whereby everyone used to where everyone brings their own stool. You'd not know how many people have entered if you didn't have a seating plan. Everyone will crowd in front. So to make things look nice, that's why we have a seating plan. All right, we go ahead. We have what's called street maps. These will be talking of the streets on the like streets of a given town. They're usually short, right? Then we have the national and provincial road plus the rail map. But these ones here, they always show the end routes. All right. Then we have what we call a strip map. We shall see it when it go. These ones are always straight, and it shows the distance always on the left and the right from a certain place to another place. A strip map. Then elevation. These are the the walls, walls of a given house when they are elevated, standing. All right, residential or housing estate. We shall look at this. Here we look at more of what floor plans, but also we can use scales. When we look at scales, we have two types of scales. We have the number scale. Other people can call it a ratio scale because it's given in the form of a ratio scale. Or we have a bar scale. These are, the other name is a linear scale. These are in form of diagrams like this. Or another one might look like this. A bar scale. All right. A number scale, for it to be 1 is 2, a given number. Usually they put 50,000. All right. And when they ask for the meaning of the scale, let me show you. Ask the meaning of the scale. We shall always say, for example, if it's 1 is to 180, the meaning will to be 1 unit on paper represents 180 units in real life. That's what we should always say when it comes to scales. Please, the reason why we use units, this is on paper. It's either centimeters. If you use centimeters, also you come down here, use centimeters. If you've used the millimeters, also here you come, you use millimeters. Why? Because these are the measurements that you can only get on the ruler. So you cannot put a 1 kilometer here and you talk of 180 kilometers from away. It can't happen. Yes, plans, these are the ones for the building, the layouts. You understand? You'll be asked to describe how to assemble diagrams. Usually they give you chairs or furniture and you describe how it's, which step first, which step next, And we go to all the context covered in maps and scales. This is usually we look at, this is when we look at it's called the, uh, the the tour. It's called planning and tour. The financial part of it. How much are you going to spend on accommodation? How much are you spending on fuel? Those things. That's when finance comes in a little bit, but it's fine. All right, we go to another part, models, whereby we look at packaging. How many, we package in different containers. We rectangular, we can pack their cans like this form here. You understand? Then we need to find out how many will fit on the long side, how many will fit on the short side. Usually we take the long side, we shall always say the long side, the length of the box divided by the diameter of the can, the tin. That simply means on the short side, we shall say the width of the box divided by the diameter of the can. But it does not only mean cans are going to be packed in the boxes. We can also pack boxes into boxes, but the arrangement will matter. That's when the confusion comes in. That's when the confusion kicks in. But what I want you to know is that if the long side is like this, all right, definitely this is the width of the box, and this is the length of the box. Then this is the length of the bigger box. Let's say maybe it's a trailer, and this is the width of the trailer. So which side is facing, which side is corresponding? So if it's like this will start with length of the trailer divided by the length of the box. Why? The length of the box is facing the length of the trailer. That means the width of the trailer divided by the width of the box. You see? That's how we... But then there's another option whereby we have other options whereby the shorter side is facing the longer side. That has to be in our little bit of common sense. We shall look at this as we go on. Here we go. We say, for example, if it's like this, and indeed you see that see the length of the box, this is the width of the trailer. Then that means if this is the length of the box, that means this is the width. And if this is the width of the trailer, this is the length of the trailer. So how many boxes are you going to find? So we shall say, on the short side, we shall say width of the trailer divided by the length of the box. And then on the long side, which is lengthwise, here like this, it will be the length of the trailer divided by the width of the box. This can also change. So we have option 1. This is option 1 and this is option 2, depending on your arrangement. That's how you shall always do it. Probability done in 2 papers. We need to know these are chances. You talk of the tree diagram. Your answers should always, answers in probability, they lie between 0 and 1 or 0 and 100%. Or you can express them as what? Decimals. Please, probability cannot go beyond 1 unless we say more than 1%. Like, it's fine. That's what I want you to know. Then there's other part that we have as a probability number line, whereby if we have an even chance, on the left it's usually possible, because if it starts from 0 to 1, this is usually possible, certain. Here we say it's what? Certain. Whereas here we say unlikely. Whereby we say it's impossible. All right. Don't forget, this is how our paper will be. Paper 2. Paper 2, measurements. We've looked at them. They contribute 83%. Plants, they contribute 60. Probability contributes 70. And we can go on. Distinction plan, it's supposed to be paper 1. You have 140. Then paper 2, you can have your 100. And you get 240 out of 300. $240 out of 300. This is the distinction plan. 100 out of 150, that's paper 1. 100 out of 150. Add the 2, you get that much. You're there. You'll be floating. This is already 80%. All right? 80% times 80% times that much. You'll be flying. Thank you very much.